Welcome to this video. In this section, we'll be looking at binomial expansion and we'll be looking to use binomial expansion of certain brackets to making estimates. All right, as you see on this very page, we've got a binomial expansion of 3 minus 2x raised to the power of 5, and they're saying us use it to estimate the value of 2.6 to the power of 5. Now, there is no reason for us at this moment, but as a mathematician, you should be comfortable with doing such things. So we already have expansion of 3, let's say we have worked out in previous sections how to expand the top bracket there. So I'm not teaching you there. You can I you can go back to my previous lessons and you'll come up with this answer yourself one way or another. So, how do we use this line here to make an estimate of 2.6 raised to the power of 5? So, what you notice is that both of these numbers have power of 5. So, that gives you a clue. So, you can set 3 minus 2x equals to 2.6 and try to solve this equation for x. What you notice is that you can swap 2.6 and 2x around. You have 2x here, 3 minus 2.6 is 0.4. So divide both sides by 2, x will be 0.2. Alright, so what you can do is simply substitute 0.2 into this line here, and bam, these 6 terms here will give you an it should actually give you a very accurate answer because we're using every term in that expansion there. We're not leaving out any other terms here. Now, when you do that, you get these numbers. Okay. And what do you notice about this very last term here? And this term next to it, these last 2 terms here. They're very small, aren't they, compared to the significant figures of these 2 numbers at the beginning? So the fact that they are getting smaller and smaller means that if we had a larger power and we had more terms here, we could almost ignore them because I know for the be less than 1%. It would have almost place in a thousandth place. So even if it was a 5 or a 6, it wouldn't make much difference to the overall number here. We are making an estimation here, and it would actually, we could ignore it. I'm just saying if we had higher powers or in general, we we can make this estimation work. Now, why can we make this estimation work? One of the reasons is that the value of x is less than 1. Okay, so you learn this in more depth when you study geometric series. So whenever you take a value of x and if this value is less is absolute sign, it could be a a negative number as well, like negative 0.2, and it would have worked just fine because its absolute value is less than 1. When we are raising it to a larger and larger power, it will become less and less significant. Now, you can test it in your calculator. Raise 0.2 to the power of 10. What is that going to be? What's 0.2 to the power of 10? It's simply uh, it has a 1 in the 1, 2, 3, 4, 5, 6, 7. Seventh decimal point. Okay, it's 0.0000001. Have I counted that correctly? Yes. So it's almost insignificant. All right. Uh, Insignificant. Therefore, we can and therefore we can call it negligible. Okay, neglected. It's okay if it's if we have higher powers. All right, it maybe power of 10 is an extreme value, but negligible. All right, so any power usually after cube is going to be negligible if the value of x is absolute value of x, I should say, is less than 1. If it's more than 1, it won't work, okay? So be careful. Don't expect this estimation work if you have x bigger than 1. It's just going to explode here. Can you imagine? Even if you put 1.1 and raise it to the power of 4, it's going to get larger and larger. But we want it to get smaller and smaller, okay? So they're probably progressively getting smaller. Why is this? Because, well, we're raising them to higher power. This is, we can ignore them because they have less of an effect. All right, so let's read this example together then. It's saying that we should first of all work out the first four terms of this expansion in ascending powers of x. So don't be confusing that. Don't start with x to the power of 10 or negative x to the power of 10. That's not what we ask to do. Ascending power of x, I explained, means start with the x power 0, 1 to the power of 10. That's going to be our first step. So when we write that, let's just answer part A first. We're going to get these first four terms. Okay? So we're going to use our calculator and our knowledge here. That's a 10 and so on and so forth. Next one is 10 times 9 divided by 2 is a 45 and so on. Now don't forget the everything we learned previously. This quarter needs to be squared. This negative quarter needs to be cubed and so on and so forth. Okay, so don't forget after this expansion 10 divided by 4 minus 4 is negative 2.5. You're going to get these three terms here if you do them accurately. Now let's read part B here. It's saying that use this expansion to estimate 0.975 to the power of 10. Correct two four decimal places. So, and find the percentage error. Okay, so there's one extra step we will have to do after our estimation as well. Okay, we'll deal with that in a minute. So that percentage error means that we actually need to find the accurate answer as well. But let's just find an estimation for it because it does say make an estimate. So what we said here is these two brackets or these two values are raised to the power of 10. So we can say let's take the 10th root here and just set them equal to each other. 1 minus x to the power of 4 will have to equal to 0.975. Solve for x. Okay, this is going to tell you what value of x to use for to substitute the value. Solve for x here. So that's the stage we are at. So we're gonna take away 0.975 and write x over 4 here, and this is 0.025. Okay, so when you multiply that by 4, x is going to be 0.1. All right, so we're going to substitute 0.1 into this expression that we have up there. Notice we have omitted the terms from x to the power of 4 onwards. We are allowed to do that as long as the absolute value of x here, x is less than 1. Okay, x is 0.1, so that's fine. All right, so let's see this substitution. I'll just solve this equation for you by hand. So now substituting x equals to 0.1 into this expression here, and you can see this last term is uh, this bracket here is 0.001 and times by 1.8, so that's going to be 1. This has already a very small value, so you can see why we can omit the other terms. So this is an estimate. This is our estimate for the answer there, that 0.975 raised to the power 10. Now, how do we calculate the actual we need to know the actual or the correct value before we can calculate the percentage error. So you actually have to evaluate it on your calculator, and you put it on your calculator. That's fine. That's what you'll get is number here. 0.776329. Notice it's almost the same up to 3 decimal places. Yeah, 6776 is the same, and then it starts to differ by a small amount. So that amount is this is the formula for percentage error here. P here means percentage error. Okay, if you don't remember it from GCSE or IGCSE, is the correct value minus the estimate divided by the correct value. All right. So what we're going to do is take these two values and find their differences, and actually you take the absolute value of the difference. I forgot to review that because it was already larger than this gives you a negative value on the top, but we ignoring the negative percentage error. It is just the absolute value sign of the error that you're going to divide by the correct value, and you times it by 100. It's almost 0.1%. All right, so that's a fairly good estimate, I would say. Okay, so I don't know what that number is there. We probably don't need that. All right, so that's it. Make sure you understand it, how you make an estimation, and how then you actually find the percentage error here. All right, so good luck. I'll see you in the next exercise.